Hi everyone, my name is Gabriel Galán. I'm a fourth-year student of EdCidi, Universidad Politécnica de Madrid, and this is my final project for EPAC, English for Professional and Academic Communication. In this video, I will talk to you about some organic compounds that are of environmental concern or are supposed to be toxic. I'll talk to you first about PAH, their properties, what they are, what are their structures, and how do they act in the human life. Then I will move into one of the most important group of pollutants known as environmental estrogens. Then I talked about fire retardants, studied by the point of view or as a contaminant or as a pollutant. And then I'll finish by talking to you about fluorinated surfactants, not as toxic as the others, but still of environmental concern. By the end of the video, I will show you, or I will talk to you about how these contaminants or pollutants get into the most remote places on Earth. As I said, I will start talking to you about PAH. They are called like this because they are polynuclear aromatic hydrocarbons. As you can see here, they are formed by two or more benzene rings attached to each other by a double carbon bond. So they can add more benzene rings. As you can see here, you can form anthracene, phenanthrene by adding a third ring to this basic structure. These are the most common PAH compounds. They have their origin in the combustion of wood and coal, but what really happens during combustion is that a chain formed by two carbons links to another two carbons chain and form four carbon chains. These four carbon chain attach another two carbon chain and form what is called the benzene ring and the basic structure of the PAH molecules. So as I said, they have their origin in the combustion, so they are known as one of the most important air pollutants. We can find them in two different ways. If the PAH have four or less benzene rings, we will find them in the atmosphere in their gaseous form, and they will rest in the atmosphere for less than a day, only a few hours. But if the structure contains four or more benzene rings, we will find them in their liquid form, and they will perform, or they will convert into a very important water pollutant. Also affects the drinking water, so it also affects us. Well, PAH are of special concern because they have cancerogenic properties, not by their own, because PAH are not cancerogenic by their own. It may occur a lot of chain reactions inside our body to get these properties of cancerogenic. What really happens is this, what scientists call the Bay region, as you can see here, is this region that promotes the start of or the beginning of these chain reactions that transforms the PAH structure into a PAH that also is cancerogenic. Leaving behind all these benzene rings, I will introduce you to the most important group, as I said before, of the environmental estrogens. They are known as this because they act into the endocrine system, the reproductive sexual system, cardio system, and that's because they are of a special concern. They affect the body because they transmit less or minimum quantities of chemical messengers that are called hormones. Hormones travel through bloodstream from the point of emission through their target, their organ target, and once there, it's supposed to occur an action. Well, these environmental estrogens have a very similar structure to these hormones, so they act by blocking or mimic these hormones, so they cannot let the action is supposed to occur. They don't permit it to occur. They affect all the environment, especially the mammals, on the wildlife and on humans, because we are mammals, but not directly the mammal who is exposed to this pollutant. Instead, the fetus or the culture is more affected by this because a change in the hormones during the development of the baby affects a in a higher way the behavior of the creature. It can promote the appearance of cancers and other problems. An example is some kind of panthers that lives in the south of Florida. These panthers are almost extinguished due to their reproductive problems, and that's because they are exposed to this kind of pollens. But how do they get to this exposure or to these pollens? Because they eat some raccoons. These raccoons have eaten before some pollard fishes. So you can see how important is this type of pollens, that they can affect a whole food chain. Other type of environmental of compounds of environmental concern are the fire retardants. Fire retardants acts once they are added to the material, they are supposed to avoid the material to catch fire, or once the fire is caught, to avoid it to expand. One of the most common fire retardants are the brominated compounds, because the brominated atoms are easily released into atmosphere, and once there, they react with the free radical change that promotes the fire, so they avoid the fire to expand. In addition, these bromine molecules or these bromine structures are easily to vaporize, so when they get into the atmosphere, they form a more density gaseous form than air, and prevents the fire from their oxygen source, so avoid the fire to expand. One example of these compounds are what I call PBDE compounds, that are polybrominated diphenyl ether, which have a very similar structure to this one. Instead, the two benzyl rings are now attached to each other by an oxygen atom, and the bromine atoms can attach to any of the 10 places remaining in the structure. So they can create 209 congeners. These congeners are numbered. As high is the number of the congener, the high is the number of bromine atoms in the structure. So instead, the toxicity of the compound decreases as the number of bromine increases. So one example is a compound named as DECA. It's used in TVs and computers to avoid them to catch fire. This compound is almost produced with 100% of PBDE 209, the most or the highly brominated compound, so its toxicity is very low. But scientists have discovered that due to the heat conditions in the TV or in the computers, the bromine atoms can be released into atmosphere, and the bromine atoms remaining in the structure is fewer than before, so the toxicity of the compound increases. There are many investigations nowadays, many sources that are trying to replace these brominated fire retardants with other materials like magnesium hydroxide or nano-sized particles that are added to the material. The last group will be the last group I will be going to talk about is the fluorinated surfactants. They are known because of their persistent properties. Once they are inside our body, their average lifetime is about 4 years. So these compounds are special because they are hydrophobic and oleophobic. I mean, they repels water and they repels oil products. All the previous compounds that we have been talking about in this video are hydrophobic or oleophobic, not both of them. So that's because these materials or these compounds are special. One of the most important is the fluorinated alkyl acids. They are known because they travel very long distances through air due to their persistent properties. But how can they travel these long distances? Well, as I said in the introduction, I will talk to it now. This is the very end of the video. I will talk about the long rate transport theories. These theories established how these contaminants or pollens travel long distances through air until they get again to Earth, in remote places like the Arctic or the Antarctic or the northern areas of the world. There are two hypotheses or two theories that explain this. The first one is called distillation hypothesis. It relates the physical properties of the compound to their travel or to the length of their travels. So, for example, a compound which temperature of condensation is about minus 30 degrees, it will travel a very long distance until they achieve this very low temperature in areas like Arctic or the northern areas, so they can condensate and get again into the surface. But for example, compounds which have a temperature of condensation, I don't know, about 13 degrees, will not condensate in the northern areas. Instead, they will condensate in the medium areas, and only a small fraction will travel into the Arctic. Well, that's the end of the video. I hope you enjoyed. Like a conclusion, I would say that we have been more conscious of what we are doing, and especially of how are we doing it. Thank you very much.